modeling. Um, let's welcome, let's wait for the others. While waiting for the others, welcome back to those who were able to attend our session last Tuesday on some NLP concepts and introduction to named entity recognition, sentence embedding, and um, to- text classification. Okay, we'll begin in a few more minutes. Uh, let's just wait for the others. Okay, so okay. Again, my name is Bash. I will be your workshop instructor for today. Here is some brief background about me. I'm currently based in Manila, Philippines. My interests include physics, artificial intelligence, big data, cryptography, Internet of Things, and robotics, and also I'm an activist. I'm currently employed as a data science consultant and AI consultant across various companies across Asia Pacific. And I currently teach as an instructor in a bootcamp company called Esquelabs. If you want to connect with me, you can connect with me through LinkedIn. I'm feel free to like propose some fun projects about social good and social impact. I'll be happy to like consult and even partake with some of your like efforts. For the code for our session today, I already created the GitHub repo. So please feel free to check it out. Uh, it contains our code from the last time and our code for today as well. You can also check out some of the articles that I do in my blog about mundane things in technology. So about data science, AI, and some of the projects that I do. So feel free to visit that and please connect. So I work in Esquelabs. Esquelabs is founded in Singapore, but it is currently based in the Philippines. Our mission is to drive social mobility in the future of work through data science education. So we build data skills for workers and teams through mentor-led project-based upskilling. So in terms of the pedagogy that we do in Esquelabs, we veer away from the typical university classes of how they teach things. Um, in a way, the pedagogy or the style of teaching that we use in Escolab is project based. So you learn through hands-on exercises, you learn from actual projects. So for individuals, we have dedicated boot camps for data science programs, data analyst programs, and even business intelligence. For companies, we also do upskilling through business to business workshops and so on, relevant to certain specific use cases. We have a new product that we offer. It's called Data Club. It's a virtual upskilling experience as a hands-on laboratory where you're guided by industry mentors to build data projects. So usually it is a 2 week long sprint that you do together with other people and learn specific topics. So it's a fun experience if you want to learn data science, learn artificial intelligence as fast as you can together with other people. So here are some of the sprint topics that we teach. So we do interactive data visualization with Power BI. We do what if analysis and optimization with Solver in Excel. We create automized export our data analysis in Python, and also do some automating in Excel. We also do some advanced level artificial intelligence if you are already comfortable with your machine learning and deep learning. So we do some introduction to object recognition. We do dynamic visualization with Bokeh, Dash, so those tools that we use in the industry. We also do designing data strategy, data governance frameworks for companies, so in a form of a sprint. And we also do customer segmentation analysis using the usual algorithms that we use. Okay, so let's formally begin our session for today. So just a recap for those who were not able to attend the lesson last Tuesday. It's okay. You can still like find the code that we use last time through the GitHub repository that we've created. But in particular, you don't need anything from it just to participate for today's workshop. Okay. So last time we talked about natural language processing. So natural language processing is uh, just basically a collection of methods and techniques that we use to analyze real language. It helps us with a lot of applications. For example, if you want to build recommender engines, if you want to build speech to text translators, if you want to build chatbots, then natural language processing is the way to go with these technologies. Okay. So I also discussed last time, this is very important, and I always reiterate this in my classes, that it's easy to do NLP right off the bat because there's so many programming languages and libraries out there that you can already use. But the problem is you should know when to use these techniques, and you should know how to properly contextualize these methods in your particular use case. So we discussed about ambiguity, right? There are certain words, different words that mean the same, but there are words that are the same but are used in different contexts. For example, the word lead. So lead, it can be used as a verb. For example, I want to lead you guys, or as compared to as a noun, with the lead as the element in the periodic table. We also talked about scale. So the problem with scale is that um, dictionaries are composed of millions, thousands and thousands of words, and it's really hard to represent it mathematically in a compressed manner. And also it's related to sparsity, meaning that important words in a document is scattered all throughout the document. And it's really interesting how we can apply mathematics to do that, but still a hard problem to solve. Again, we have the problem of variation. There's so many like variation in terms of the language that we use. Language is always evolving, right? How we speak 10 years before is different to how we speak now with our new jargons in terms of how we use like internet slangs and things like that. We also have the problem of expressivity. So it's about the semantics of how we express meaning through words and expressions. And we have the problem of unmodeled variables. So for example, many words are created um, every day. So it's like really like interested on how we can try to incorporate this in our models. And the last problem would be unknown representations. So what worldview should we imbue our algorithm? So for example, if I drop an egg, for example, what will break, the egg or the floor? So things like that. It's really like hard to completely comprehend for the computers same worldview that we have. Okay. So we also discussed basic operations and the pipeline that I recommend using Spacey. So we will still use Spacey for our workshop for today. And don't worry, this is a code along session, meaning I'm going to require you to open a Jupyter notebook or PyCharm or whatever environment that you're comfortable with to type in with Python. So we're using Python for our workshop for today. So last time we talked about tokenization. So tokenization is when you have a sentence, you want to get the individual words of the sentence. So that's tokenization. We also talk about lemmatization. So lemmatization is getting the root word of the word. So for example, I have the word sentences. If I lemmatize it, I get the word sentence. We did tagging, so part of speech tagging. We also did parsing, so identifying dependencies. For example, what is the subject of this noun and things like that. And then we also discussed about entity recognition. So how we are able to identify certain words of interest in a document. For example, how will we teach the NLP algorithm that apple used in a sentence can be a fruit or it can be the company Apple? Okay? Whew, that's a lot to discuss, but as compared to last time, this will be a more hands-on workshop. Okay? This will be a hands-on workshop as compared to last time. So last time we discussed about um, a lot of these concepts, but now this will be more of physical activity to you guys. So I think my colleague already sent the link for the code for today. Just visit that link. I hope it worked. Um, so again, it's Shopee 2021 under my repo. The name of the file would be Shopee Code League 2021 Day 2. Okay, so I'm gonna give you some few more minutes to download it. Okay. I hope you are already like familiar with how Jupyter Notebook works as well. So check out the chat. I think my colleague is always like updating the link for those who have just joined us. Okay, let's begin. Okay, the objective of our workshop for today is to teach you three things, okay? I want to teach you TF-IDF, so term frequency and inverse document frequency. So that's the first thing. Then we need to teach you how to do sentiment analysis, okay? So we're also like implementing sentiment analysis using Vader. And then the third one would be topic modeling, which would be the bulk of our discussion today and the motivation of those two previous topics. Okay? Okay. So I also mentioned last time the concept of sparsity, right, in natural languages. So I mentioned to you the concept of the Zipf's law. So if you remember ZIPFS, Zipf's law. So Zipf's law states that given a large number of sample of words, the frequency of that word is inversely proportional to the rank of that word. So it means that if I have a word, for example, the article the, you can find a lot of those words in a document, right? So the and those kinds of common words. So the thing is, they are very common. They are a lot. They are very frequent, but the importance is very small. You don't need those words, right, to understand the context and the intent of your document. Okay, so that's the motivation of the Zipf's law. And again, the mathematical translation of the Zipf's law is called the TF-IDF. Okay, so let's just wrap our minds around the mathematics behind it. Don't worry. Just stay with me with the math. We're gonna go with it together. So the first formula that I will introduce with you guys is called the term frequency. It's very simple. It just counts the frequency of the word in a document and then normalize it. So meaning it will like get the weighted frequency. Okay, so the variable n here specifies the number of occurrence of a word in a document. So for example, I have a sentence like, we flew to Mars last week, for example. So the occurrence, for example, of the word Mars is 1 over the total number of words in that sentence. So that's the term frequency. Okay? So that's term frequency. It's easy, right? I just used an elegant way of doing it to express it mathematically. Okay, the next term would be inverse document frequency. So this is a logarithm of n over df. So this factor here is a measure of the rare words in a document. Okay? So rare word in a document, because if you have a document, for example, I have a book here. I have a book here, for example. Sometimes there are like words that are very rarely mentioned in the book, but they are uh, key words in that document. So, for example, if you're holding a Bible, a name would be mentioned only once, but it is a central character. But it will but just be referenced by a preposition and so on. So, we use inverse document frequency to find those rare words because they might be important later on. Okay? So, okay. So DF-IDF would be the combination of these two things. So we get the most frequent, the frequency of the word, and then we multiply it to the inverse document frequency. So the final formula for a TF-IDF score is this one. We multiply the number of occurrences of that word, multiply it to its importance or log n over df, and then we get the score of how important that word is. Okay, we will try to demonstrate it later through an example. Oh, not actually later. We can demonstrate it now. Okay, so for this time, I want you guys to open your Jupyter notebooks and code along with me as I type in the code. So I'm gonna share another screen, so hope you can follow. Give me 1 second. I'm just gonna share my Jupyter notebook. Okay, I hope you were able to see my screen. So again, my instruction is that if you can visit the link to the repository that I created a while ago, and then open the day 2 Jupyter Notebook file, you will see some code here already that I initiated. Okay. Let me just check piece of the chat. Okay, let's go ahead and copy some of these items to our Jupyter notebook. So for example, this piece of code here um, just installs the dependencies that we need. Okay, so I want you to remove the comment here. So just delete this one. Uh, delete the hashtags. So just delete the hashtags and then run the cell. Okay, let's just give it some few more minutes to finish running. So these are the libraries that we will use later on to do the TF-IDF. But the TF-IDF, we're gonna code it from scratch. Also use some of these libraries to do topic modeling using um, common algorithms. Okay, so it's done. So again, my instruction is remove the hashtags on these items here. It will install all of the things that we will need, all of the libraries that we will need to run this workshop. Then again, go back to the repository that I gave you and then copy this piece of code here. So here are the we will now call the libraries in Python, okay? And then run it. So again, to run it, it depends on your system. If you're using Windows, if you're using Mac, but generally it's like shift enter. Okay. So these libraries include, we will create a word cloud, we will do some plots, we'll do some iterations on our list. We'll use GenSim for topic modeling. We'll use NumPy for some mathematical calculations. We will use Spacey for the NLP part. We'll use math again for some calculations. SciPy to deal with the matrix that we will use later, and then normalize in scikit-learn we will use again for dealing with some matrices. Okay. For GenSim and modeling, we'll use these three models, LDA model, LSI model, and HTP model. And we will use coherence model to evaluate the performance of these models. So you need to install this one. And then we need to use a data set in GenSim. So you need to like run this code here. And then we will then visualize the topic models that were generated using GenSim, using PyLDA Vis. Then NLTK is what we will use for removing the stop words or the noise in our sentences or our documents. We will also like demonstrate how we can automate things through scikit-learn through the TF-IDF problem, and then some requirements to like find the file, doing regular expressions, and so on. Okay. Yes. Again, you need to uncomment the zip code, the hashtag. So remove it. So remove the hashtags for you to be able to run it. Okay. So I hope you will able to run it. Make sure that you have all the libraries. Okay. Make sure as well that you have the correct and latest version. So again, if you are having like problems, for example, you cannot install word cloud, just type in Google like pip install um, word cloud. And then you will get instructions on how you will be able to install it depending on your system. Okay. So yeah, just navigate through the documentation and yeah, it's also like fine to use Google Colab instead. So again, for those who are using Google Colab, that will also like work if you don't have a local version of Python working. So Google Colab also works. So after running all of the modules, the next thing that we have to do is to copy the next piece of code. Okay. So here's the next piece of code that we need to copy. Okay. This code, basically this function here, um, will convert the document later into Unicode. So it's easier for Python to read the document in text form. And then, so this line here will get the test data for us in Gensim. And then we are getting this particular file. So lee background.corpus. So what is lee background? So lee background consists of 300 documents selected from the Australian Broadcasting Corporation's newsmail. So we will use the news data set for our topic modeling and for our TF-IDF. Okay, so I need you to run this piece of code here. So run it. Okay. Next thing that we have to do is we need to open the file. Okay, so to open the file, I need you guys to code along with me. So I encourage you to do half screen. So half screen would be the Zoom, and half screen would be the interface that you use to type in your code. Okay. Okay. So I want you to define a variable called text, and then we will open the corpus that we will use for our sample. So lee train file. We'll open it lee train file, and then we're gonna read it line by line. Okay, and then now we will use Spacey to load the dictionary. So it's the same dictionary that we've used last Tuesday. So type in NLP Spacey dot load, and then type in what is the dictionary that we used last time. It's English Core Web. The small version is enough. So if you were able to like type in, just copy this one. Okay. So type it this one, and then what's the next things that we, normally in a large corpus, there are many noise words, right? Like you don't want those words to be there. So we can like get the stop words. So it can get the stop words. So these are the noise words that we don't want, that we also would like need to be removed. So for example, stop words is equal to stop words. I think we imported it right from NLTK. So these are the noise words that we need to remove from the document. So stop words, dot words, and we would want the words to be English. So just type in this piece of this piece of code here. So if I shift enter and then check the content of stop words, it contains a list of the words that are common in English that is not important in a sense. For example, I, me, myself, you don't need those words, right, in a document when you're doing NLP. So we need to remove it in our specific use case. So these are just common words that clutter our data set, and it will add dimension and complexity to our models later on. So we need to remove it. Okay. So I'm gonna like remove this one. Let's remove it. And then to remove it in our document, we can type in this code. So for stop word in stop words. So let's do for loop. Let's say, so the lexicon or dictionary, let's remove it in our vocabulary. So remove those stop words, so those noise in our vocabulary will not be called later on. So stop word, and then let's remove it by passing the argument lex dot is stop is equal to true. So, okay, again, just type in this piece of code here and then run it. The next thing that we need to do is to call in the document. So document is equal to call in NLP. Let's call in our text here. So our text is the Lee background corpus. Again, this is news from Australia back in 2000 something. So we just call it. So we apply the function clean. Remember, we defined this clean text to convert the text into Unicode so that our computers can read it. So clean and then type in text. And then shift enter. Will just take some time for it to finish running. Let's just wait for it to finish running. Okay, so it's done running. So let's check the content of. Okay, it's normal that you don't see this line here because I added a library in my widget for me to time it. So don't worry if you can't see this like line here. I just added it as a library. You can check it out on Google if like how to do this. But it's just a cool function to see how long the piece of code is running. Okay, so if I type in doc, this is the content of the document. Okay, you will see, okay, these are a lot of news headlines in Australia during 2000. So it's a lot of document, and this is what we would want to apply our NLP contents. Okay, so here is just a sample document in doing it, and now we will apply the things that you've learned from on Spacey last time that we discussed it. So I want to get the individual words and maybe clean this document first. Okay, let's clean it and get only relevant words. So for example, let's create a empty list. So let's define it text and then article. Let's create this two list here, text and article. It will contain all of the words in the document and all of the articles segmented by a new line. Okay. So for W, for words in doc, um, okay, if W dot text is not equal to backslash n, so backslash n in Python is a new line, right? So a new line here, for example, this is one article. If it started with a new line, it's another article. So we're getting the chunks of articles from the document. Okay? So if w.text is not a new line and not w dot is underscore stop. So these are the stop words. We're also removing the stop words that we defined earlier, and not, what else do I have to remove? And not a punctuation. We don't want a punctuation. So w dot is punct. Again, if you are asking for the keywords or the arguments that I'm using, just check the documentation in Spacey. We have provided this last time. So Spacey documentation. So all of the like code that I am using, you can always check it out through the Spacey documentation. So it's always here. Okay? So the piece of code that I am typing, you can check it out here. So going back to the code, so w dot is punct and not, what else do we have to, we can remove the numbers as well. So w dot like number, I don't need the numbers for this particular use case. Okay. So after doing this, I can define article. I cannot append my list. So article dot append. Article dot append w dot lemma. So we're getting the root word of the words only. Okay. So, but if, let's create another if statement here. If w dot text is equal to a new line, let's just append the text. So text dot append article. So it signifies an article. Then type in article is equal to new list. Okay. So if I run this piece of code here, so shift enter. Okay, I made a mistake. What mistake did I do? There's no text. So wrong spelling. did, did I do this wrong? Uh-huh. Yeah, I did this wrong. Should be texts. Text should be with the letter S. So if I run this one, it should be correct now. So if I check in the list text, I should see all of the words, right? All of the lemmatized words already. So you can already see it here that the code that we had here, the for loop, just takes in all of the individual words of our articles, right? And then it separates the individual words per article. Okay, so we have here the first article, and then the next list would be the second article, and so on. Okay, so that's convenient if you want to like process the document article per article. Okay. Okay. The next thing that I want to do, I still need to clean this. So here's the problem with doing with um our stop words automatically recognize there's a question. Um no, you need to pass it. You need to pass this argument here that you, yeah, I think you need to pass it here. We need to define the stop words first. But it is not recognized automatically. We need to have a list containing those stop words. Yes. So these are the lemmatized words. The output of the text here are the lemmatized words. Okay. But we still need to clean this one because what's the problem with this one is that there are still like capital letters. I don't want that. Okay. So okay, what I'm gonna do, I'm gonna simplify things. So I'm gonna type it transform texts is equal to let's join in so you can see clearly what I am telling. So let's join the words first per article. So join for I in text. So you can see what I will be doing here. So if I look at transform text, transform texts, okay, you will see here that, okay, I joined again all of the words together. The next thing that I'm gonna do after joining it, let's type in text 1, and then let's lower all of the words. So I dot lower, so this is the function to make it smaller letters for I in transformed text underscore 1. Okay, if I type this one, there's no such thing because it should be just text. Transform text, there's no spelling. Tran, I forgot S. Okay, so if I look at transform text 1, I should see that all of the words should be small letters. So that's correct already. Okay, and then what I need to do is to do some magic. I'm gonna remove all of the what's the problem that I can see here. So remember that we removed the numbers earlier, but the problem is that if you look closely, like for example, I remove all the numbers already, right? So if I type in, for example, 5. So the problem is that if the number comes together with a word, it will not be removed. So I need to remove these numbers because for me, it is not relevant for our analysis. Okay. So what I need to do is to define transform text to, we will use regular expressions. So re.sub. So we are defining a pattern. So we're how to do this. So let's define a pattern using regular expressions. If you're not familiar with regular expressions, you can go to regex 101. So regular expression is just a way for us to like find patterns in strings. So for example, I'm looking for numbers. So you can use this cool tool to like find patterns in a document. So let's find all of the words with digits on it. So let's try this pattern. Let's try all of the like letters with digits. So digits, backslash D is for digits, and then backslash word, and then get all of it. Okay, so is this correct? Then I'm gonna replace it with an empty string. So basically, I'm just removing it. Then I regular expression blah 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 blah, then dot strip. Let's strip for I in transform text 1 or I in transform texts 1. Okay, so basically we're removing this items here, some numbers with letters with it, with this code. Let's see if it works. Okay, it worked. So now, let's do the TF-IDF, okay? So the TF-IDF, don't worry, I will be sharing the notebook after this slide. So just, if you cannot do it right now, just listen to how we do it step by step because it's important down the line if you plan to use this. I need to copy this piece of code here. So remember the equation that I gave you a while ago? It's the implementation of that equations. I know it's a bit long, but feel free to code review it like line by line. We can see that. Remember that we defined inverse document frequency equation a while ago. It's just math, logarithm n over the total count. I just added the one here because um, there might be an instance of 0/0. We don't want that. So I added like a mathematical like magic here. I add one to the denominator and the numerator to not have that scenario. And then remember that the TF-IDF is the multiplication of the term frequency multiplied by inverse document frequency. So it's the formula here. So it's here. So this is the term frequency. And here is the IDF, which we define with this function. Okay, so let's just run these functions here. And then let's try to use it. So to use it, I will first use this function here, the fit function. So what it will do, okay, it says that it returns two things, vocab and IDF. Okay, so let's try and test this one. So let's try vocabulary and IDF of vocabulary. Okay, and then let's call in the function fit. And then what does it need? It needs the whole data, right? So we need to pass in what's our data. It's transform text to. So I just need to copy this one and then put it here. Okay. If I run it, just take some time for it to finish running. Yeah, because it's a big it's a like slightly bigger document. It's it's done. So let's look at the contents of vocabulary. If you look at the vocabulary, so basically what it contains is that it contains the word and its count, right? Remember that yeah, it's just the number of words and it's not really the count. Um, it's not the count. It's the placement of words. Then if you look at IDF, so remember IDF is a measure of the rare words. So if I look at IDF vocabulary, let's look at the rare words. If I look at the rare words, okay, you will see that these are the calculations for the rare words. But the problem is it's not in order. So it's not in order. So what I need to do, we can sort this dictionary first. So let's type in sort IDF or like sorted IDF. Sorted IDF. Let's try and define a dictionary, pass in that dictionary. Let's call in the function sorted, and then IDF underscore no IDF of vocabulary dot items. I'm getting all of the items of the dictionary, and then let's define the key. So operator dot item getter one. So I'm just like sorting out the result, like who is the highest um who is the highest uh for example highest TIDF value. Okay, so if I pass it this code and try to run it, will it run? Okay, so if I try to look at sorted IDF, there's no such thing because you should be I will see that, okay, so here are the assortment of words. Okay, let's now look at the word cloud. So I hope you were able to like install the word cloud. So to do it, here's how you do it in Python. Word cloud, word cloud is equal to um, call in the library that we call, so word cloud dot generate, no, this is the wrong syntax. Dot generate from frequencies, and then let's type in, for example, vocabulary. Okay, and then we need to show it in this cell. So plot dot, we need to use matplotlib imshow to show the results. Let's show word cloud, and let's just like pick some few words, not every word to be shown in the word cloud, so it's not too cluttered. So interpolation is equal to bilinear. It's the usual um, parameter that I use, bilinear. Bilinear, that's correct. Then let's remove the axis. So plot dot um, axis. You will see that it's the same value right now because we haven't yet cleaned it. But yeah, because we ranked it, right? So obviously it will show like the same like value for now, but down the line you will see that it will change if I print everything. So let's continue with this code. Plot that axis, let's turn it off so we can like remove the x-axis, and then plot.show. So if you run this one, you will see, okay, so these are the words. We just printed the vocabulary, right? And remember that the contents of the vocabulary says dictionary of just like the listing. So A to Z. So obviously, since the Z like words are like the highest count there because we're counting from A to Z, it should be like the one shown here, okay? But if you want to see the like rare words, for example, so we can like replace it. I'm just copying this cell here, copying it here, and then replace vocabulary with IDF of vocabulary. Vocabulary. Okay, I run this one. Okay, you will see that, okay, these are the like rare words. Again, in order, starting from letter A. You can also, for example, if I don't want to see AMer, because for me, for my particular analysis, it's a noise word for me. I don't want that word. You can remove it by extending your stop word list. So how can we do it? So you can do it. Remember our stop word list is stop words. We can type in dot extend. Let's make a list and let's remove the word AMer. Okay, and then we need to like apply this to our text file. So I need to use counter to count it for me. So stop words dictionary is equal to, let's use counter to make a dictionary out of that list. So stop words, and then I need to define transform texts underscore 3. The last one is we had 2, right? And then let's just join them together. So dot join. Let's join the words now. Removing the word ammer. So to do that, I need to do list comprehension word for word in I.split. I need to split that. And then if, let's make a if statement, if word not in, if word not in our dictionary. So stop words dict, and then for I in. So it's a long list comprehension. Bear with me. It's just a long. And then the last one is like where we will apply removing this one, transformed text underscore 2. Okay. So just need to run this piece of code here. Hope there's no error. Okay, I think it worked. So for us to see if it worked, I just need to copy this one, and then paste it here, and then um, run it, like replace this one. Let's replace this one. Okay. So our original text before, so for example, we're gonna apply the word cloud for um, the text, transform text to a while ago. So let's like apply this one. Oh, this. Hmm. 1 second. Maybe this should be 3. Huh. Give me 1 second. I'm facing an error here. Hmm. Of course, this should be wrong because I need to redefine my vocabulary here. So I need to get this piece of code here, this one, and then I need to reapply it to text 3. Okay, so just paste it here, and then we need to fit it again, and then like replace this one with um, this one. So we can compare that if we have removed the word ammer already. Okay, so if I like replace it with this one and run this, it will take some time before it finishes because it's running this function again. Okay, so as you can see, if we compare these two word clouds together, I just remove here the word amer because I think, for example, I don't need that word. Okay, so, but the problem is our implementation is still just IDF. It's not TF-IDF yet, right? So we're just using the function fit, and fit only returns IDF. If you want to see the really important words, remember because IDF shows you the rare words only. TF-IDF shows you the important words. So we need to use transform for it. Okay, so I created this function transform. So to apply it, okay, let's try it. So let's call it like final output. Final output is equal to, let's call in the function transform. Transform, and then we placed in the argument, what do I need to put to transform? It requires me how many arguments? So we need to put in the data set, the vocabulary, and the ITF values. Okay? So we need these three arguments. So what's our data set? Our data set is transformed text underscore 3. Then we need to place in our vocabulary, and then the last one would be our IDF underscore vocabulary. IDF underscore vocabulary. Okay, vocabulary. Okay, if I apply this one, IDF vocabulary is not defined. Yeah, because it should be IDF of vocabulary. So it should run. Okay, and then if I look at the final output, you will see that, okay, these are the final TF-IDF scores that we want. Okay, whew, that's a long like run. So again, I'm gonna do a quick recap of what we did. So so first, like we installed the prerequisites, then we imported the required libraries, then we imported the test document that we will be using, the Lee background corpus for our analysis. Then we load the data set using, we load dictionaries for our reference in Spacey. We implemented like removing initial stop words. Then we call in the document. Okay. Then after calling in the document, we remove some things. For example, we remove stop words, we remove punctuations, and we remove some numbers. Then the next thing that we did is we cleaned the data set furthermore. We lowered the number, we lowered the text, so we removed anything that's like caps lock. And then like we remove other digits that were not captured previously. And then yeah, we just define these functions to compute the TF-IDF measures from the equations that I gave you a while ago. And then we applied those functions, getting the vocabulary and IDF. So the vocabulary is just the list of words in our document, and IDF are the rare words. Okay. So we showed you the um, word cloud of the vocabulary and the IDF, but it doesn't tell us anything. Okay. So what we need to do is to like get the word cloud of like a cleaner version of it. So the cleaner version should be the word cloud of final output, which will provide us this will provide us the important words in our document. So if I copy this piece of code here and then paste it here and then replace this with final output, it should like create a word cloud with more sensible results. So output. So if I type it here, whoa. So you will see now, these are like the important words that I should look at. Oh, this articles are talking about virus. They're talking about cow, maybe a cow disease or something. It's talking about casino or drug or spill or farmer. So those kinds of issues. So again, TF-IDF is very useful when you're looking for important words in your document. And that's amazing that we can like use this. So what I showed you is doing it from scratch. Like me like interpreting the equations that I did, but there's a shortcut. Okay. Now I'm gonna teach you the shortcut. You don't have to implement it from scratch. To use the shortcut, we will use scikit-learn to do it for us automatically. Okay. So let's use scikit-learn to do it for us. Okay. So to use scikit-learn, it's really easy. It's like just three lines of code in scikit-learn. So you don't have to do it like from scratch. Okay, so in scikit-learn, so let's place a comment. TF-IDF implementation with scikit-learn. So scikit-learn is a common library that we used in basic feature engineering and machine learning. It's really like convenient. So scikit-learn. So to do it, okay, I just defined TF-IDF. TF-IDF is equal to, let's call in the import that we did a while ago. What did we import? This one, TF-ID vectorizer. So TF-ID vectorizer, and I will just put in some parameters. So for example, on top of my head, because I usually like, I always do it, so I like most probably memorized some of it. But if you don't, feel free to visit the documentation of scikit-learn. So it's all there. Okay, so let's place in some arguments. So minimum degrees of freedom, for example, let's put 5. Let's normalize this using some form of regressor like L2 regressor, for example. And then I want to change the encoding. So encoding to Latin 1. So I would be sure that my words are in a certain format. And then for bigrams and n-gram range, I'm just putting here some parameters that I know on top of my head that would like work for this. But definitely you can like try in. It's also like very easy to like remove stop words using TF-IDF. You just need to type it here like stop words, stop underscore words is equal to the stop words that we defined a while ago, like the list. So it's really like simple. You don't need like tedious list comprehension that we did earlier. So stop words. So okay, so I hope this works. So that's the IDF already, and we need to apply some. We need to fit it already. So I define in a features is equal to TF-IDF dot fit transform. So we're gonna fit it. Fit transform. And then let's put in our text document. So what's that? That's transform text underscore 3. Okay. Then let's define this dictionary as this one. So there's a question, is there a difference between using L1 and L2? Of course, there are different types of regressors and you can play around like the results. So it depends on the data set. I'm just trying out random values here. And definitely if you want to check out other like iterations and combinations of parameters, feel free to like experiment. And I encourage that you guys experiment after getting the code, play around like what will happen if I change the minimum degrees of freedom, for example, to 10. So things like that. Feel free to do some experiments on it. Like we are all scientists. Vocabulary. Vocabulary. Oh, spelling. Vocabulary. Underscore. Okay. So to type it in, so there's wrong. There's something wrong here. Yeah, I forgot to place in equal sign. Okay, it worked. So if I look at the, okay, so we can now use our word cloud to do it for us because these 3 lines here already did for us what we did for like a couple of lines previously. So now I can like call this one and just put in the, how convenient, like, see? So it produced a different one because I think I optimized it with like more like sensible arguments. But this is really like there was like a cutoff from the code, so sure. So I'm gonna put it there. Yeah, so you can see it. So n-gram range, remember when dealing with words, we can do like 1 gram meaning just one word, bigrams meaning 2 words. For example, New York. If you're using 1 gram, so that's separate words. But if you're using 2 grams, that's New York altogether. Okay. So I just used one n-gram here, so just for convenience. But it's how you can implement it in um, that's how you can implement it in scikit-learn. You can also like improve the graph. For example, this is ugly. I hate this one. So we can like maybe improve this plot here. So how can I improve this one? Let's pass in some arguments to make it prettier. Okay. So I can, what can I do to make this prettier? I can add arguments here. I can add arguments here. For example, let's change the background color. Background color, let's change it to white, for example. And then, what else? Let's say max words, maximum words is equal to 2,000, for example, if I have so much words. And then let's change the size. So for example, if I want to have like a width of, let's say, 1024, and maybe a height of, let's say, 720. So we got that like kind of resolution. And then what else do I have to do? We can also like change the resolution of the image to just make it like better. So we can type in plot that figure, plot that figure. Let's change the dot per inches to the DPI to 1000. Oh, it will like render slow if I do this, but it will produce a better image. And let's like change the size of the figure by something not squarish, so 20 by 8, for example. And then let's put in title, so plot dot title. Let's put in word cloud, word cloud, and then what else? Oh, geez. I think this will work already. Yeah, you can like run this one again, and you will see that it has an error. Why? What did I do wrong? Background, white, max words, width, height. This should be equal sign. Okay, so it will like render for some few minutes so I can rest my vocal cords. Oh, it's ugly. Why is it ugly? I did something wrong. It's the position. This should be like in a different position. It should be, where should I place this? It should be after here. So it will like do this configurations first before showing it. I hope this works. Okay. While running, take a breather. Like remove your eyes from the screen and like hold your chair to be mindful about your surrounding. Oh, it's done, but it's not showing. Why? Oh no, it's still loading. Like my computer should see. That is better. It's high resolution. I can see the pores on that image. So yeah, you can see that it's like better. You can see like more words because I did like a cap of 2,000 words to show for it. So it tells me more about the dynamics and intricacies of the word cloud that we produced using TF-IDF. So again, the part here that I was showing you is about right, TF-IDF. Okay, I need to stop sharing my screen. I hope you were able to like to follow through, but don't worry, we'll be providing the code later on. I need to like move on to another topic. Yeah, this session is really condensed. I know, right? Because we would want to really like apply a lot of these things to your outputs. I'm really excited to see the things that you will produce from it. The next thing that I have to introduce, I will no longer discuss the mathematics behind it, but I will lead you to resources if you're really interested in knowing the math behind it. Okay. The next thing that I need to discuss is doing sentiment analysis with Vader. Okay, this is really simple. Um, so VADER stands for Valence Aware Dictionary and Sentiment Reasoner. So it's what we use to find sentiments. So it's a lexicon. So a lexicon, what is a lexicon? I'm always telling you like a lexicon, blah, 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 a while ago. But a lexicon is just a list of words. It's just a jargon. But lexicon is just a list of words. That's simple. Okay, so Vader is a lexicon and a rule-based sentiment analysis tool that is specifically designed to extract sentiments expressed originally in social media. So they use it to like analyze sentiment on Twitter posts, like Facebook comments, and things like that. It's open source, so it's like really like fun to um, play around with. So, for example, a positive lexicon. So, I mentioned that a lexicon is a list of words. So, a positive lexicon is just a list of all positive words. So, for example, good, amazed, appreciable, etc. Those positive words. So, this is just a list of words in the lexicon. So, similarly, negative lexicon is a list of all positive negative words. So, like bad, abolish, ambush, etc. So it's really simple how this algorithm works. It's a rule-based approach of sentiment analysis. So where each words of your product reviews text pass through those two dictionaries or lexicons. So it's like positive and negative words list and count the number of positive and negative words in your review text. So for example, I have a text. I will just count all of the positive words and then I will count the negative words and just sum it up. Okay, and the general sentiment of those that sentence depends on the number of its positive words and negative words that we cross compare in the lexicon. Okay, so it's really simple. Again, I'm going to reiterate. Um, a Vader is just like dictionaries of words. It contains dictionary of positive words and dictionary of negative words. Okay, so given a sentence, for example, to know the sentiment, you just count the positive words and just count the negative words. Okay. Simple as that. So what do we have to do next? We need to implement it with our data set. So I'm going to go back to our code. Please head back to your code as well. Where's that code? Okay, I hope you can see the code. Okay, let's start a new line here, sentiment analysis. So sentiment analysis is really like simple to implement in Python. Very, very straightforward. So for example, this is just like a single line. It's really easy. So let's define our model. So type it SID. So SID is the thing that we've imported a while ago. Where is SID? This one. So we're using Vader in NLPK. So sentiment intensity analyzer. So just call it here. Um, analyzer. So this should work. And then, so for I in range, length of, what's our document again? It's transform text underscore 3, and then text underscore 3. Okay. So we're just iterating through the articles that we have defined a while ago. And then let's just print it. So let's print all of the articles. So let's print articles. What are those? So transform text underscore 3, and then I, and then let's add like a semicolon to separate from the sentiment scores, and then let's define the scores. So the scores is just calling in SID dot polarity scores. So positive, negative, neutral. So those three things that we would want to measure. So polarity scores. And then call in this one. I just copy this one and then type it here, and then let's print the scores. Print scores. Okay, so if I run this piece of code here, you will see that it will print every article or every like header in our data set, and it will tell you the okay, the score is negative 0.138, uh, the neutral score is 0.751, the positive score is 0.11. But how do we interpret it, right? So to interpret it, we use the compound. So the compound is just the weighted sum of these three things. So it just sums the negative, the neutral, and the positive, and then like in a weighted sum sense. So it tells us that the compound score is negative 0.5994. Since it's negative, this article here is somewhat like talking about a negative thing, right? A negative scenario. It has more negative words in it. Okay, so let's find another. So, right. So most of the articles here are negative, like highly negative, because later on you will see when we do topic modeling, all of these articles, most of these articles are about war, okay? About war, about disease. So normally we can confirm, oh, this is correct because most of the sentiments on each like header or sentence is really like negative. Okay. So see, it's really easy to do sentiment analysis. Like mathematicians already did the job for us, and we have this cool tool from NLTK to find sentiments from sentences. And we're not confirmed to like doing text. It can also like read emojis, so things like that, as I've shown in the previous slides. Okay. Ha. Now, we're down to our last topic, and I think the most comprehensive topic so far. So this topic is about topic modeling, okay? So in basically, like in its most simple sense, yeah, I will give resources later, okay? Don't worry. Like at the end of the class, I will point you to some resources later if you want to like explore the intricacies of the models that we're using, if you want to explore the intricacies and the parameters of the libraries that we are using, I will like point you to that direction later on. Okay, but I just want to, for us to align how to use these things, these tools with Python. Okay, excuse me. So topic modeling is like a very simple concept. So for example, I have many documents around, like lying around, and I want to have a sense of like summary of what these articles are about. So topic modeling is about like finding certain topics that are common across corpus or documents. So for example, we have these two documents about Jurassic Park and the Cretaceous Tertiary extinction. So we find commonalities that, okay, these two articles can be like described with these three main topics. So this might be about like dinosaurs and extinction, and it might also be about amusement parks. So it's really like exciting that computers know how to do this, right? Like you don't have to read like volumes and volumes of text. Just have your computer identify it for you. Okay, so bear with me. I will discuss some very technical term, but I will try to dilute it so it's easier for us to understand. Again, if you're not afraid of the mathematics, I can point you to some articles later on. But for every one of us, because I'm not aware, um, of all of your like levels, will stick to the basics first. Okay, the first thing that we have to discuss is um, there are three main algorithms that I want to teach you for this lesson on topic modeling. So it's the first one is latent semantic indexing. So basically, it's just like if you're familiar with like linear algebra, singular value decomposition, and PCA. It's just that. It's just PCA using text. So latent, what's the meaning of latent in English? Latent means hidden. It's hidden. So the goal of latent semantic indexing is to find hidden patterns in the text. Okay. So again, if you're familiar with singular value decomposition, it's basically doing dimension reduction, right? So for example, if I have like 1 million words, I want to apply matrix operation to like just compress this 1 million words into like 100 words that could represent those 1 million words. So it's similar to something like that. Okay. So it's really easy to implement because of like most of the programming languages that we do now can handle big matrix operations. Okay. Right. Whew. The next algorithm would be like harder. So it's one of the like more common algorithm that you will see online. So for example, if you're gonna search on Google about topic modeling, latent dirichlet allocation is one of the like more common algorithms that we use. Okay, so using LDA or latent dirichlet allocation, one treats each topic as a distribution of words in some known vocabulary. So you have like a bag of words, for example, and you will just like pick random word. Or, well, not really random. It's based on the Dirichlet. It's based on the Dirichlet distribution. So it's really like hard. Like the math is a bit hard, but you don't need to understand it fully, right? To understand that it's just like a distribution of where you like sample like words through this distribution from a bag of words. It's that simple. Okay. So for each document in a mixture of topics, for example, we draw from a Dirichlet distribution, and then each word in the document is an independent draw from that mixture. So it's that simple. We're just like getting words from a bag of words using a Dirichlet distribution. Okay. So on the other hand, the next type of model that I want to teach you is a hierarchical Dirichlet process or HDP. It's very simple. It's just an extension of LDA. It's similar because they use Dirichlet as a process. So HDP is designed to address the case where the number of mixture components is not known. So because in the latent Dirichlet allocation, for example, I have a large text. I need to do topic modeling. In LDA, you need to define how many topics do you want. Okay? So for example, I have a many documents. I want to choose only 10 topics. So that's how you do it in LDA. But the good thing about HDP is that it's similar to unsupervised machine learning, meaning you don't have to define that number of clusters. Okay, it will find the optimum number of clusters for you or the optimum number of topics for you, as you will see later on with the code. Okay. As far as for the pros and cons of LDA versus HDP, I know I know that HDP has the advantage, no, that the maximum number of topics can be unbounded and learned from the data itself rather than being specified in advance as compared to LDA. Okay, so that's really like the important difference here that we need to understand. Um, it's not really complicated to implement, and like I will show you how it's done. Okay, so again, we have three models that we will use for topic modeling. Latent semantic indexing uses SVD, singular values decomposition, to reduce the number of topics based from words. Then we'll use latent Dirichlet allocation, draws like words from Dirichlet distribution, and hierarchical Dirichlet process, just an extension. of LDA using a unsupervised machine learning approach. And then for us to measure the performance of these models, we will use some topic coherence matrix. Again, the rule here, the higher the coherence number, meaning that the words are related to each other, the better. Okay, the better the model is. Okay, it's code time. So we need to get back to our code. Code time. Let me share my Jupyter notebook again. Don't worry if you are like lost right now. It's normal. The first time I studied it, I was lost for ages. Like I was lost for weeks. You need. I'm gonna be honest with you guys. You can't really like master this right off the bat. You need to go through this with grit and perseverance to go through the materials again and again until you understand it. It's normal if you're lost right now. Like same. I feel lost as well when I first like was studying these materials. But bear with me. Again, we will practice like reinforcement learning. So as long as you will see it, so just like absorb it, don't worry. Okay, let's start. We will use GenSim for topic modeling. So I'm gonna type here topic modeling. This is the last section of our workshop. So for topic modeling, remember I discussed a while ago about n-grams. So in this a particular problem, I want to use bigrams, meaning I want to connect words together that are like related. Okay. So for example, if you recall our text, so for example, let's recall our texts. You will see that, for example, in Australia, um, New South is not like two separate words. It is one word. So the first thing that we need to do is to use a bigram to connect words that are related. Okay? And GenSim contains that model to like combine words that are related. Okay? So how do we do that? Okay. So I need to type it here. So let's define a variable named bigram. So bigram is equal to, let's call in GenSim. GenSim.models then dot phrases. So it will like go to the libraries of GenSim and find similarities from there. Then we put in texts and then we define texts again. We redefine text again and we're going to use the bigram. Bigram. Then we use like again list comprehension line for um, line in texts. Okay. So if I run this piece of code here, oh, it's fast. And then type in the word text again, you will see now we have combined the words that were recognized by the GenSim model phrases, right? So New South Wales is now like one word. Let's find another one, like Southwest is now one word, right? It makes sense to really like process things using bigrams because it's really like common to our language and so on. Okay, okay. So for us to be able to apply like topic modeling in GenSim, we need to like abide by its rules. So to do that, we need to like change how the data set looks like. So let's define a dictionary. Dictionary, we will just like reformat the text here so we can use GenSim to process it. So dictionary is equal to dictionary. So it's a library in GenSim and then we put in texts. And then we define a corpus because corpus is what you need to input to a GenSim model. So corpus, again, the code that I am typing here is the standard. So if you go to like tutorials online, it's the same that I am doing. Okay. So dictionary, definitely you can study it like later on. So dictionary dot all of the things that I'm writing here is also like available in the documentation of these libraries that we are using. So I need to convert this document into a bag of words. So just like a random, like just like a soup of words. So doc2 BOW, so bag of words, text for text in texts. Okay. So if I run this one, what will it do? Ah, and check in the content of corpus, you will see that yeah, it what did it do? It converted the list of words that we had a while ago into vectors. That's really interesting. Now, since we have converted the words into vectors, we can apply mathematics to do it. Okay? Okay, so cool. So let's try the first model. So what's the first model? It's the LSI, right? Okay. So the LSI model, you can use GenSim to do it. So LSI, let's type in LSI model is equal to LSI model, and let's put in some arguments. So corpus is equal to corpus, and then um, LSI model is similar to LDA, latent dirichlet. You need to define the number of topics that you want it to have. So for example, number, no, it's wrong. Number of topics is 10, for example, and then ID to word, so to our like vector form, ID to word. Let's put in our dictionary so it can like cross compare that from our original word. So LSI model, corpus number of topics is 10. ID to word is dictionary to place it there. Okay, I think this will work already. And then we need to look at the topics. So LSI model dot show topics. So I type it here. Oh, cool. So you will see that it found, of course, it has 10 topics. So 0, 1, 2, 3, because it's like predefined here that we need to have like 10 topics. And for example, the first topic is about, it's about say, it's about Mr., it's about force, it's about people, Israeli, Australia, kill. So it's about like some form of like war within like the Palestine or the Australian and the involvement of Australia with it. Second topic would be Israeli, Palestinian, Mr. So there's a certain persona. So again, like topic modeling is very, very similar to unsupervised machine learning. It's not really labeled. You need to define how you would want to relate like these topics together and like combine them into like a like one word description that you want it to have. Okay. I will also like show you a trick. For example, I don't want to see all of the 10 topics because it's too long. You can like type like num topics is equal to 5. So you will only see like this 0 to 4 topics here. It will not like overwhelm you. Okay, it's like shorter. See, it's very simple. Okay, that's the LSI model. I need to proceed with the next model. Next model would be, let's try an HDP, the HDP model. So hierarchical Dirichlet process. So to do that, so HDP model is equal to HDP model corpus is equal to corpus. We don't need to define the number of topics. Remember, I mentioned a while ago that using HTTP, it will find the number of topics by itself. Okay? Because it's similar to like an unsupervised machine learning like algorithm. So I just need to type in ID to word. ID to word is equal to dictionary. And then let's just show the topics. So HTTP model dot show topics. Okay, so if I type in this code here, I hope there's no error. It's correct. HTTP model is not defined. Why? Wrong spelling because like it should be like big M. Because remember, like the imports that we have, it's like HTTP big M. So that's my fault. So I run this one. Huh. Show topics. Why? Yeah, wrong spelling. I'm too careless to be a good programmer. So you will see that it found how many topics? It found, oh, a lot of topics. It found 20 topics all in all. So This is the good thing about HDP because it will find the number topics on its own based on like some patterns that it found. Okay, and the last one would be the LDA model. Like, LDA model is very similar. I'm a bit lazy. I'll just copy this one. I'm just copying this one and then copy this one, paste it here, and like replace things. So replace this with like LDA. What else should be replaced? LDA. What else? That's it. Same corpus. Let's say the number of topics is 10 and ID to word is something something. And then I need to run this one. Okay, you will see, okay, these are the topics found by it. Okay, and also like remove this one to see like all of the 10 topics if you want to like compare. So you can see all of that. Okay, the next cool thing that I'm gonna show you is that it doesn't make sense to have these models. What now? So we have like LDA, we have like HTTP, we have LSI. What now? So the cool thing about like GenSim is that it provides us some way of visualizing it to like to show our like the colleagues, hey, I did this visualization. So I'm gonna give you like a 2-line code to visualize all of these things. So let's call in Pi LDA viz. So let's visualize the LDA one. LDA viz dot, let's enable first to for it to like render correctly in our Jupyter notebooks. So enable underscore Jupyter notebooks, the syntax. So this one should work. And then uh, pi LDA wrong spelling. It should be S. Visualization is S, not, yeah, it should be S. Pi LDA vis dot gensim dot prepare. Then let's call in LDA model, for example, LDA model. Then let's put in corpus, and then let's put in dictionary. So if you type this in, it will just render for a few minutes, but it's really like interesting if you see. Yay, so it run. It's really cool. Like you can visualize like the topics that it produced. You will see that there is a clear distinction between topics 1, 8, 10. And this is a dynamic visualization. So you can hover your mouse and look at the colors. Look at like the certain words like associated with it. So for example, you will see from this algorithm that, okay, topic 1 is really legit because it's like far from topic 6, for example. But I'm not resolved with like topic 5 and topic 3. They're like, there's a big overlap and they might be just like similar with each other. Okay? This is fun if you can like explore topic modeling more. So my computer is lagging. So but annoying. It's fun to like see the topics and you can like describe them better. Then you can like this is like topic 0, these are the then next topic, you explore topic 1, blah blah, so you can see, okay. So there's a question here. If you run HTTP model on the same corpus a few times, it will give you the same number of topics each time. Well, it depends. It will not give you, because remember HDP is a hierarchical Dirichlet process similar to HD. It draws randomly from a Dirichlet process. So every time it will get a different word. So definitely it will change the topics, but it should not be like too different. It should be like still related, but yeah, the topic should be still like related, but the actual words that are picked are of course different because you're drawing from like a different set of bag of words. Okay? All right, it's fun, but I'm not yet done because we need to compare the performance of these 3 models. Like, what's the best one for me to use? Now, I can visualize it, I can compare it. Which one is the best one for me to use depending on my use case? So this is the last topic, so bear with me. This 2 hours is long. So I need to what do I need to do next? I need to get the coherence score or the performance of these models. Okay, so to do that, um, oops, my fault. My screen is changing. Okay. So let's okay, define some variables to define our coherence metrics. So I'm gonna type it some few lines of code. So LSI topics is equal to, let's get all of the topics. So each word of the topics. So um word for word. And then let's get the probability in topic for uh, topic ID, topic in LSI model dot show underscore topics formatted equal to false. Okay, then I'm gonna copy this line of code here, replicate it for the HDP and the LDA. So I'm just gonna replace this one HDDP and then LDA. For word topic, this should be the same except for the last line. So this should be, what's this one? HTTP and then LDA. Okay, so then if I run it, I hope there's no error. HTTP model, there's no such thing. HTTP model. Why? HTTP model. HTTP topics. You put HPD. Ha! See, I'm too careless to be a teacher. So HDP. HTTP. Okay, this should work. HTTP. Huh, it worked. Next, I'm gonna define the coherence score. So I'm gonna like type in LSI underscore coherence. LSI coherence is equal to, let's call in coherence model. And then let's just take in the top 10 topics. I think it will be enough. So let's type in topics. Um, topics is equal to LSI topics, and then just let's cap it to just the 10 topics, and then define text is equal to text dictionary is equal to dictionary tapos let's define the window size for our comparison matrix. Window size would be just 10, and then is this enough? So window size would be 10. I think it is. Okay, so then just type in that get coherence. Okay, so I'm just gonna copy this piece of code here and then replicate it for HDP, not HPD. So HDP, this is LDA. What else do I need to replace? This one, so should be HDP and this one should be LDA. Okay, is this correct? I think it's correct. Oh, I I made like a wrong thing here. Hmm. Okay. 28 topics. I already capped it to 10 a while ago. But anyway, okay. Just type it here. Then let's try to run this one. Will it work? Yeah, it's still like calculating some things. Okay, it worked. So the next thing for me to do is to like plot it. So to see the different scores. So I'm gonna make a function to plot it. So for example, so def evaluate bar graph. And then let's put here as an argument the coherence says, and then the indices. Okay, so what do I need to plot? Let's assert that the length of coherences should be equal to the length of the indices first before it runs. So coherences is equal to length of the indices. And then n is equal to like the length of coherences, and then x will be just like a range of numbers. So this will be, let's use numpy, np dot arrange n. So we're just plotting the scores, okay? So the coherence score, just plotting it. Then let's define like a plot, a bar plot. So bar plot would be like x, then coherences scores, and then let's define it like width is equal to 0.2. Let's place in tick labels. That would be the indices. So that's where your like x-axis go to. And then let's align the bar chart. Um, let's make it centered. Okay. And then let's prettify it by adding labels. So plot.x label should be like models. And then plot y label would be your coherence value. Coherence value. Okay, if I run this piece of code here, of course, it's just a function. It will not output anything. Let's call it first. So evaluate bar graph, and then let's put it here. The coherence values as a list. So let's put in LSI coherence, and then what else? The HDP coherence. And then the last one would be LDA coherence. And then let's put in the indices. So the indices that I wanted to have, of course, like the simplified names, LSI, and then HDP. And the last one is LDA. Okay, so if I run this last line of code here, oh, there's a name error, HDP. What did I do wrong? Indices. Spelling. Indices. What else? Oh, spelling. Rectangle object has no property tick labels. So, ah, again, my spelling sucks. Sorry, guys. Yeah. So you can see here, here's the performance of the models. Like the best performing model for this particular analysis that we have is the LSI because it contains the highest number of like coherence value. Okay, so here's like just one method that you can test the performance of your topic modeling that you can like cross compare. So this is really helpful to objectively say to your like managers or to even like wherever you want to present this one, that okay, the best model for the topics is from like an LSI model and containing these topics and so on. Okay, I think that's it for the coding part of this session. I know it's a lot, but let's run through it again. So for this session, we discussed a lot. So mainly three things. We discussed about the TF-IDF, and then sentiment analysis very briefly, and then topic modeling. So TF-IDF is very important for us to determine the important words in a corpus. Okay, it lets you get the balance of the rare words and the frequent words in your document. So it's really handy if you want to really like know like word importance in your document. Second one is sentiment analysis. It's very useful when you would want to quantify like proxies to emotion to your like document if you want to know like the sentiments of people using your products or even like the contents of the document itself, then using Vader is one easy and handy tool that you can try. And the last one would be topic modeling. We tried three models. So LSI, what else? did we try HTTP and LDA. So I'm gonna move away from the screen and then please share my screen back time. So here are some of the topics again that we discussed. So latent semantic indexing, similar to SVD. So it just reduces the dimension of the phrases and the words to get like optimal number of words and topics related to each other. Latent Dirichlet allocation, it just like gets like random words from Dirichlet distribution and like consider those as the topics. Then hierarchical Dirichlet process. Usually this is the best performing model from my experience because it's unsupervised. You don't have to tell the number of topics. It will find it for you. So I usually go for HTTP when doing topic modeling for consulting, for my consulting like gigs. I usually use HTTP. Okay. And here's some of like the things that I want you to look at. I'm gonna go back to my uh, browser to give you some resources that you might be interested to like use moving forward. Okay, give me just like a few minutes. Okay, the first one would be again like my bias, like teaching with Spacey to supplement the things that you've learned from me with Spacey. I want you to try this out. So, of course, that Spacey, it's free, and we're not gonna offer you something that's paid. So it's always free. I love like open source technology because we're moving towards a learning culture. Like everything is available online for free. So that's really like a good thing about innovation. We can make a lot of things for free. So go through the exercises here. For example, the things that we've gone through last Tuesday, it's here already. There's a discussion, there's a video, there's some quizzes that you can try out to practice your Spacey and NLP. Again, my recommendation if you want to move towards a career in natural language processing, study NLTK and study Spacey. It's like the two of the best tools that's out there to like start your career with NLP. Okay, it's very comprehensive. The courses is really good. It's provided by the creators of Spacey themselves, so it's really like a good resource that you can definitely try out. Okay, the next thing that I need to give you, as I've mentioned, NLTK would be the best complement you can have for studying NLP. So here is like a book. It's my go-to book when I study like the libraries available in NLTK and the mathematics behind it. So feel free to like there's a good discussion as well on how you can install things in Python, how you can make it work in your environment. So things like it's very user friendly. Okay, you can like find different chapters here that describe like how to get information from a text. It's very clear on how it can like segment things. Again, mix and match and own your own learning. Again, these resources will be like always be out there, but it's up to you, your grit, your motivation, and like pursuing and studying these kinds of things. But definitely feel free to reach out to me if you have some questions with this like topic area. Feel free to connect through LinkedIn. What else? I love like studying through like projects and hands-on things. So I would recommend you to like check out this website from Quantum Stat. So it contains like a good number of like models and even papers that you can try out. So here is like a repository of state-of-the-art technology and even data set that you can find for NLP problems. Okay, so for example, if you want to explore different languages aside from English, so for example, for Indonesians, you can like find amazing data set here. So Philippines, keep up. We don't have enough like libraries here, so I need to create it when I have like more free time. But this is a comprehensive library that you can use to train your models and so on. If you want to like analyze Twitter of like a certain demographics, then this repository is definitely helpful. Okay, for those of you who don't have necessarily enough or not really like confident with your programming skills, still you can like study through this provided Jupyter notebooks already. I think I based some of my materials here. So again, it's from NVIDIA, it's from TensorFlow, it's open source, it's from practical.ai. For example, if you want like model sparsification, if you want to do apply GP3, for example, or like understand TF IDF. It's also here. There's a like corresponding notebook that you can check out. So just click the notebook and then you will see the code is already there. So this is a really dope repository. For example, even if you didn't understand my discussion, it's okay. But like find it here. For example, one hot code in encoding, even topic modeling is here as well. Like topic modeling with GenSim. Here you go. It's like a free resource that everyone can use. This is very handy. What else I have to give you? Um, give me 1 second. Last item that I need to give you would be this one. So again, the code is here. You can like check this repository here. It's really comprehensive. Last one would be this one. The GenSim documentation is already here. If you want to explore other applications, even with other models, feel free to like check this out, how you can like visualize results and so on. So it's very handy, these resources. And again, I think my colleague Thea here like already like chatted the links for these repositories, these resources. So feel free to study it on your own time. Again, one important like tool that you can use as well would be regular expressions. So visit regex 101. Not really like regex 101. Regex 1. Yeah, you can like try free like problem sets that you want to like explore. For example, I want to like find and match all of these strings. Then what like pattern do you have to do? There's a cheat sheet here. So definitely you can like try. So it's fun to try around these kinds of things. I want to find the numbers and so on. Let's try this one. Okay. What else? I think that's all for my end. I think it's time for me to welcome some of your questions um, moving forward. So let's just wait for some of the questions. Is it also normal that we have different outputs for the LDA model in PyLD? Of course, it's normal. Again, it's drawing from a distribution. Of course, the other models can be visualized as well. It's just like LDA is the default, but you can also try it with other models, definitely. Again, you will have definitely different results. Uh, if you want your results to be replicable, what you need to use is set a random seed for it. So type in random.seed and set random of seed so that every time you run the code, you will get the same thing. So just set the same random seed. What are the applications of topic modeling? What are the main advantages of topic modeling? So applications of topic modeling is on document summarization. I had some clients from law firms, for example, they have volumes and volumes of text, for example, and then they would want to like, hey, can you summarize this like group of documents for me because we don't have time to read all of the constitution, all of the law. So it's really like simple to just apply topic modeling to like, okay, this law is about these three things. It's as simple as that. It's really useful. Like it will automate and make simple a lot of the things that we do manually. So not only that, like even banks apply topic modeling. For example, I tried applying topic modeling to complement optical character recognition. So in the Philippines, a lot of the things that we do are not automated. So we have like a lot of paper trails. So they give me like PDF. Then what I do, I scrape all of the parts of the financial statements, for example, and I do topic modeling to like segment, okay, these are the money. Okay, these are the entities. These are the to pay people, and then the location, the address. So I use it. I use topic modeling to segment certain topics. Relevant to coronavirus, I also did a project with some of my colleagues. We use topic modeling to scrape websites from different agencies. This was way before when COVID was just starting. So there was not enough accurate numbers except for news media because they really like fast to the news. So we scrape news agencies in the Philippines and use topic modeling to get the numbers and to get inconsistencies with them. So there's a lot of possible applications of topic modeling. Again, sees the limit. Sky's the limit. If I want to extract data from the graph, what library should I use? I didn't. If I want to extract data from the graph, what library should I use? Let me share that once again to answer that. All of the items produced by your plot here, it's available from these three items. So definitely you can get it already from these three items, from your LDA model, from your corpus, and your dictionary. Okay? So is there any NLP project for novice you would recommend for data science resume? Is there any NLP projects for novice? I would recommend what would be relevant right now. It depends on the context of where you plan to apply it. But in terms of if you want to use it in your resume, I would suggest getting data from e-commerce companies because it's a boom right now. Like a lot of companies are, we're in a pandemic. Most of the activities that we do are online, right? So if you can do some NLP project on like understanding sales in Shopee, for example, promoting Shopee, of course, you can scrape like data from Shopee API, and then you can like do some NLP project to get the sentiments of the customers, do topic modeling of the trends in what products are being bought. That would be really like interesting to like find. Where can I read your white papers and articles? Um, I post a lot on LinkedIn. Like most of my engagements and my articles, I post a lot on LinkedIn. So please follow me on LinkedIn. I do have some upcoming talk with Mozilla Festival. So if you want to learn about cryptography, how you can like hide messages in your video, in your picture, I will do some talks on March. So connect with me through LinkedIn so you will be like updated with some of the conferences that I will be attending. What else? What do you think about personifying chat? So another question here. You can also like, by the way, visit my website. So it's just like a GitHub pages. So I post there once in a while, but like my main go-to is like LinkedIn. So here are some like articles that I like curate. Feel free to like read it. It's free. If you want some tutorial about like time series and so on, I'm doing machine learning. Okay, let's address the next question. I need to share a different screen. I need to like again, while I'm answering my questions, I'm encouraging you guys to give feedback to our session so we know how we can improve our sessions for future engagements with you guys. Really appreciate negative feedback loop so we can always improve the way we conduct our job. So what do you think? Where can you find the legend for the coherence scoring? Find the legend for the coherence scoring. Let me check that again. Legend for the coherence scoring. Coherence score. So it should be here. Like the legends here. You can get the coherence value if you type in this one. Of course, for example, if you want to check the coherence value for LSI conference, so just type it and it will print the value for you. It's that. That's how you can like get actual value. What do you think about personifying chatbots? What do you think would be a plausible approach? Um, Personifying chatbot, it's already been in the pipeline of research from Siri, from your Amazon, from Alexa. They are at the forefront of doing it. But yeah, there's some benefit of it because it's the experience. It's tailor fit to your actual need. But then again, as I mentioned last Tuesday, technology is a double-edged sword. It's a dialectic thing. It can be used for good. It can be used for evil. If you personalize it too much, then you're giving too much personal information in that technology. It's really like hard to dissociate from technologies that we use. So you need to be wary about like personifying it. We need remember that as technologists ourselves, we're still humans. The technology that we should be building should be an extension of our humanity. So it's really important to talk about human-centered design and ethics as well because it's really important. NLP is other applications would be fake news, deep fake. So it's really like not only the positive things that we should like discuss, we should also think about how we can safeguard this technology because it can be used for like malice, misinformation, disinformation, and so on. Again, like knowing these tools, we are responsible for like securing its use. So for a complete beginner to NLP, do you recommend us to start with using a certain model? Again, for me, as a data scientist, tools and models are secondary. Okay, when I hire data scientists in our company, in our startup, I always like see to it that the person is a good problem solver first. So the tools programming, it can be learned. There's so many resources online already. It can be done through enough practice and grit. But the important thing is you need to learn how to solve problems well. You need to know how to ask the right questions. What type of problems that you want to solve. But as a beginner of NLP, you need to have like a good context of what problems can be solved by NLP that is relevant to my application. For example, I'm a student. I want to use NLP, for example. I'm a physics student. I want to use NLP to um, describe the things that I do in physics in context to my country, for example, the Philippines. I would want to know through topic modeling what are the topics that are most published in physics in my country. So things like that. But then again, don't focus too much on the tools. Focus on your problem solving skills because it matters more than the tools. Tools can only be can just be like pulled out there, so it's like really easy to get. Right, more questions. Are there any interesting NLP subjects or news updates recently or new models that is like interesting to learn? Definitely, like and the algorithms produced daily like by Google, by TensorFlow, those kinds of like companies, GP3, like they're like creating very hard to like um discern news articles. You think that okay, this is like a legit like article, but then again these models were able to like really replicate the way that we write, the way that we like do things. It's kind of scary but kind of cool in a way. But again, there should be like more conversations and like safeguarding this technology. But every day a lot of things are published, so I encourage you to be a continuous learner because it will like help you like move forward in this data world, right? We're always learning. Even if you graduate in college, you will always have like opportunities to learn. Even in the work that I do, I'm not a trained programmer because I'm doing physics. Now, some of the things that I do a lot of software development. I do QA testing. I do web app development and front end development, even back end. So that's really like interesting. There's a lot of things that we can learn, but again, focus first on the problems that you are solving. The tools are just secondary. Last question before we end this call and workshop. So recommendation for beginners to improve coding and data science skills. Um, do project-based learning. Um, Visit Kaggle, like explore on the code of other people, join hackathons. The thing that I learned while studying like data science is that uh, knowledge sharing and learning should not be in the burden of just the individual. The best thing to learn for me is to learn with other people. There's a saying that if you want to go fast, do it alone. But if you want to go far, do it with other people. So find friends with common interest, code with them, like encourage, hey, I'm gonna code this Saturday. I'm gonna learn JavaScript, for example, this Saturday. Would you join? And be accountable with each other. That's I think would be like one of the great like way for you to learn. Join hackathons together, learn together, find mentors. It's finding mentors is very important. Like I'm nothing without my mentors because like in the data industry, it's really small, but it's important that we are connected more than ever because the technologies that we are producing is always connected. We affect everyone wherever you are in the world. We're always like affected. So yeah, I think that's it on my end. I'm really happy that I was able to like share with you some of the things that we do. I hope you learned something in this workshop. And please feel free to connect with me through other resources. And I appreciate that you are like beginning your journey through like the data industry because it's becoming more and more relevant